It's been a little while since I've been a lab analyst. I actually started out my career in the chemical plants as a lab analyst, but then I was a work process coach for a while, and then eventually I went into operations towards the end of my career. But I'm teaching here at Victoria College now, and I teach process technology. And our main role for process technology is for those who are going to go and become operators at the plants. But I was kind of surprised. Last year we had a couple of students who got hired on as lab analysts at Formosa. So a lot of what we teach, it can be utilized towards working at the plants, and we teach some analytical um, testing in our labs that we do. So, and then a lot of the benefits to working as a chemical process operator, you get a lot of the same benefits that you do as a lab analyst. So there's a lot of overlap there. And then there's some people who start out as lab analysts and then get into operations, and then there's some operators who start their career as an operator and eventually get into the lab. So, like I said, there's quite a bit of overlap there. Uh, I'm going to try sharing my screen now. Hopefully everything works well. I'm not as familiar with. Can y'all see that where it says background? Can y'all see that okay?
Yes, sir, we can see it.
Okay, it's not working in the presenter mode, so I'm going to just have to do it this way here. So I have my degrees are in education, actually, in ag education to be specific. I worked for over 9 years as a county extension agent. Many people are not real familiar with what a county extension agent does, but I worked with youth in the 4-H programs. I worked with the farmers and the ranchers. And then after doing that, I was actually in Goliad County at the time. So a lot of my parents, especially the dads, worked at the chemical plants, and I kind of got burned out on my old job. So I decided I was going to look into going and work at the plants like these other guys were. I'll talk a little bit about the benefits, but probably pay and time off, time away from work, and that were the big ones. I actually interviewed for both a lab position and an operator position about the same time. And then when I got a call and they were giving me a possibility of an operator job, but then they said, or if you want the lab job, it's yours. So that's how I ended up going into the labs. So I hired on with Union Carbide, which is now Dow Chemical, and I spent over 9 years as a lab analyst. So why did I become a lab analyst? The big ones were pay, benefits, time off, and job security. So I'm going to get a little more into that a little further down in the presentation. But first of all, a lot of people, including myself, before I hired on out there, I just knew those were the plants out there. I knew they may make plastic or they make chemicals. I have very little idea what they do. So before I talk too much about a lab analyst, I want to talk a little bit about what the plants, what they make and what their purpose is. So these plants take raw materials, which they obtain, a facility obtains the raw materials, and they're processed by people, equipment, and methods to produce a product. Sometimes these products go to customers, like retail customers, and a lot of times they go to other plants to be further processed. For example, we all know how important plastic is in our lives. And while we have a lot of plastic plants in our area, or another word for polyethylene, it's everything from insulation on wire and cable products, to cups, to things around our house. If you look in our cars, plastic is pretty much everywhere. And a lot of times it gets a bad rap, but I think now with this COVID-19 scare and all that, especially in the medical field, they realize how important plastic is, because a lot of times we need things that are disposable, that may be contaminated, we can simply throw away. While we do believe in recycling, there are certain things, especially like I said in the health industry, that plastic is very important. But looking at the process industry, a lot of different areas, and that includes pharmaceuticals. And actually, there's a pharmaceutical plant just south of Corpus in the little community of Bishop in that area. Power generation, we have South Texas Nuclear Project not too far from here. We have the Coleto Creek Coal Plant. We have STEC. So that's actually considered part of the process industry. And but what we mainly are geared towards in our PTAC program is chemicals. And like I said, plastics is a big part of that, but there's also ethylene oxide products, ethylene glycol, and a lot of times it's breaking down, like for example, at Formosa, they take natural gas and they make ethylene, which is further processed into polyethylene. So there's a lot of different products in this area. I know Ineos makes products that are specialty plastics, and anyway, so that's the chemicals. Then we can look at the next block on there. It talks about refining, and that includes everything from the oil field all the way to the refineries that make gasoline and diesel and jet fuel. There's also the pipeline part of the industry, and that's simply, a lot of times that's just the main thing, is just moving the product from where it's produced to the next part of the industry where it's further produced into materials that customers can use, such as gasoline. Then moving on, we have food and beverage, and we don't think about that too much, but we actually in Schulenburg, we work with a company called Dairy Farmers of America. They've hired a few students of ours, and they produce dips, like for Frito-Lay dips. I think they produce like 60% of the dips that Frito, what they call shelf-ready dips, produced nationwide by Frito-Lay. And finally, the last one is pulp and paper, and that's probably the least emphasis in this area. You have to go all the way to East Texas to really find any kind of pulp or paper mills. Okay, so next, and then I just included this slide here. A lot of times we drive by these plants and they're really, really large complexes, and it can be pretty intimidating when you just look at them. But a lot of times after our students go through some of the program, they say, oh yeah, well, we have cooling towers here, we have spheroid tanks, we know those hold things like butane and propane that are under pressure. We know these are columns here, and so you start breaking it down and you can kind of figure out what's happening in that plant. But now, like I said, most of my recent years has been more on the operator side of things. And so now, but I started out as a lab analyst, and just some of the things that a lab analyst does is they have to maintain analytical equipment. They do maintenance on the equipment themselves a lot of times, if it's minor, just to keep it working properly. But a big part of that is we would do daily calibrations. Before you run tests on product, you have to make sure your material or your equipment is working properly. So you would run standards, and from that you would determine, make sure everything is working properly, and calibrate your equipment as needed. We'd also test in process and raw material. By in process, we mean we take samples. This wasn't necessarily the final product, but these in-process samples tell us, are we running our process correctly? And sometimes we would test raw materials as they come in to make sure we're using that they meet the specs. So you have to have good raw materials so you can end up with a good final product. And then finally, the final process samples to ensure product quality, we would run tests on that to make sure that it meets the specs of what the customer is looking for. There's also testing that these lab analysts will often perform, that is on air emissions and water quality. The plants have a license to operate in our areas, but you have to meet your agency guidelines. TCEQ, Texas Commission on Environmental Quality, is the big one there. And we have to take care of our environment. Some other things that the lab analyst has to do on occasion is assist operations. When things are failing, you start having problems in the plant. The analyst and oftentimes is part of a team that helps troubleshoot the problems. It also involves training others, training new analysts coming on, maybe working with operators. Sometimes, maybe they're not sure on pulling a sample, how to pull the sample correctly. And finally, a lab analyst also has a responsibility to be constantly learning. A lot of times we find better ways of testing or improved testing. It may involve training new employees, and there's always safety. Safety is something that's always emphasized at the plants, and so we want to make sure that we have frequent trainings on safety to meet OSHA guidelines and just to keep our people and our employees safe. And then there's a lot of different analysis that are done depending what type of lab. If you're, most of my familiarity, I was in in what we call a poly lab. And so a lot of high tech equipment. We use this here as a gas chromatograph, which it's to find out what is our components, our product, what does it contain? Does it have the right amount of additives in it? This next machine is a melt indexer. It's how well does the material flow when you heat it, how thick or how hard it is. Sometimes we would have to do titrations, or what they call a wet chemistry or wet chemical lab. This bottom picture is a scanner where we would take the polyethylene and do what we call extruding and make it into a tape. And it was an optical camera in there that would look for contaminants. The place I worked, we had to produce very clean product because it went into medium and high voltage cable. So any kind of contamination, especially a small, tiny speck of metal, could cause a failure of that cable when you're talking 60 or 80,000 volts or more. When you had that high voltage, a metal contaminant would cause it to blow out or to arc, and it would leave the cable. So that, like I said, it was also kind of interesting about the time I was working in the lab was when some of these TV shows like I believe it was NCIS or the forensics, and they would talk about FTIR analysis and UV analysis. And it was some of the same type of tests we were running in our lab. So a lot of these tests that we run are used in forensic labs and other types of labs as well. Okay, so some of the skills required as far as education and training. Yesterday I talked with one of the hiring persons at Formosa, and she said really that they kind of, the qualifications, there's different ways of hiring in, but some of them they sometimes require 8 hours of college chemistry. So that would be two semesters of chemistry. But depending how you hire in, that might not necessarily be required, because there's a company called Taurus, and Taurus a lot of times provides lab analysts like on a temporary basis. And you may, if you get experience with Taurus, you may not have to have that 8 hours of college chemistry. So there's, associate's degree is sometimes required if you're hiring straight in and not going through Taurus. It sounds like they have a lot of flexibility in their hiring, but just because they have, it may be low minimum requirements, you got to realize that it may be competitive, and so you want to do everything you can to not just meet the minimum requirements, but to have an edge. So focusing, if you take as much chemistry and as you can, and if you have electives, take more chemistry if possible, and make sure you really are good. Now, granted, in some of the labs, it's not a whole lot of chemistry involved. Like the poly labs probably use less chemistry than the what we call the like the chem and gas lab that we had at where I worked at Dow. But it's still good to know the chemistry and know what's happening in the process of your plant. Technical knowledge and experience, and like I said, sometimes to get hired on as a lab analyst, you might have to go work as a contractor lab analyst first. Like I said, there's Taurus at Formosa, and I believe Kelly Services is the company that Dow uses now. So Kelly Services may hire as a temporary lab analyst. If you go work in a unit under contract, and then they have a position come up for a permanent position, oftentimes they will hire that Kelly Services individual. Interpersonal skills, you have to be able to talk and communicate with people, get along and work as part of a team. Like on the communication skills, you're going to need to communicate with operators. You may be communicating with engineers and chemists, so that's always a big plus. Computer skills, even in our operations training, we get a lot of students who a lot of times say, well, I really don't like computers. I really like to work with my hands more. But computers are a way of life now. We've kind of found this more and more now, especially with the COVID-19, working online, computers are just one of those things that the more you know about computers and the better your computer skills are, the better your chances of getting hired. Physical ability, a lot of times we don't think that physical ability is that big a deal in the labs, but a lot of the lab is shift work, and with shift work it's 12-hour days and or 12-hour nights, 12-hour shifts. So that can be on your feet up and down quite a bit, going to check on this test. And you have in the lab, one of the things I learned is there's a lot of multitasking. You have to be able to start this test, and while it's running, you go over here and start another test, and so you're doing all this multitasking. So you're up and down on your feet quite a bit. But the other thing with physical ability is we had a test that we ran. It was required an 8-kilogram sample to actually run the test, but 8 kilograms is a little about 17 pounds or a little over. And so when the operator brings the sample material, it's a much larger bag. It's over 30 pounds, 30 to 40 pounds. You had to handle this bag, and at the same time as you're emptying it into a hopper, you're having to handle it real carefully in kind of awkward positions so you don't contaminate the product. So there was some physical ability there. Dealing with change anytime, and these are kind of, a lot of these are generic. Almost any job you go into is going to have a lot of these same skills required, but you need to make sure you can think of situations if you get an interview of where you had to use your interpersonal skills or use your communication skills. But dealing with change, one thing I learned about dealing with change in the plant is, we started out as Union Carbide, and it had its unique culture and way of doing things. And in 2001, I believe it was, we became Dow Chemical, and that with the merger with Dow. And then there were several times we had talk of mergers, and even more recently they have merged with DuPont. And so every time you have these mergers and acquisitions, there's things change, rules change, policies change, and with that you have to maintain a positive attitude. You have to go with the flow, because it can be very stressful if you don't. And finally, the last one I mentioned a little bit earlier about time management, multitasking, and job prioritization. It's really easy in the lab. You get into kind of a certain routine, but you also have to be willing to, because that routine brings a lot of efficiency. A lot of times you get your routine and you can go through and run your samples quickly and efficiently. But at the same time, if you get a failing lab sample, you have to be willing to get out of that routine and help operations troubleshoot, let them know that, hey, there's a problem, they need to go off grade or what have you. And so you have to be able to prioritize your jobs. Okay, and so next, what's in it for me? So kind of going back to why did I decide, I had a career with, like I said, with the County Extension Service, and it was working with 4-Hers and youth, and it was pretty rewarding. I enjoyed it, but the pay wasn't all that great. After I went out to the plants, it was only a matter of a few years before I practically doubled my salary. The plants are very lucrative. I mean, it's one of the best places or best jobs in this area. So there's the monetary gain. When you look at from a family standpoint, there's pros and cons with shift work. If depending on where you work, I'm not going to say you're going to get all this time off, because some units have a lot of overtime and you end up having to work quite a bit overtime. But I was fortunate when I became an operator, I worked in a unit that I could kind of pick and choose. If I turned it down, usually somebody else would take the overtime. And so I was able to get time off for myself. Now, we'll talk a little more about shift work and how that works in a little bit. So freedom, you get a lot of freedom with that time off. And by finally giving back, that what we're talking about there is you can give back to your community, you can volunteer, and so you can volunteer your time, your talents, and your money, because when you make good money, it's easier to donate and help organizations out. Okay, a little bit on the financial side of things. This is kind of geared a little more towards like I said, our process operators, the people we train here in our PTech program. but it applies pretty well for lab analysts too, especially if they get hired on and don't go through the route of working as a contractor. Like I said, I was really surprised this past, not this May, but last year, May of 2019, two of my students actually ended up working for Formosa in the labs. But if you look at what it costs to get a degree, and if you look at what you make afterwards, that's how this analysis is done. AAS and PTAC cost you approximately $20,000 for 2 years in college. Keep in mind, we also offer a certificate program where in 1 year you can possibly get hired on. A lot of the plants are hiring students who just have our certificate. The starting salary is approximately $50,000. And a lot of times by year 3, you're making up to $70,000. And in years 4 and 5, a lot of times with overtime, it's not out of reason to think that you might be making $100,000. I mean, the plants have really, there's been more demand recently, and the salary scale has gone up somewhat. So if you compare that to a Bachelor of Science degree in engineering, where you're looking at a 4-year degree, if you can complete it in 4 years, you're looking at about $100,000 in cost of college, and the starting salary is about $70,000. So their starting salary is a little bit higher if you get an engineering degree. Okay, so this next slide is just kind of a comparison of money coming in and money going out. So the blue line is for a process technician, or it could be for a lab analyst as well, because talking to Formosa, I really didn't get word back from the other plants. From what I know of Dow, when I was a lab analyst, the pay schedule was the same for analysts as operators, and I think it probably still is too. Sometimes they're kind of hesitant to put out this pay scales, and it's because they say it's all based on their steps along the way. But usually the analyst, from what I know, are the analyst versus operator pay scales are pretty close. But anyway, back to this graph. If you look, the blue line represents the process tech or the lab analyst. And so the first 2 years, if you notice, the line drops down, and that's because it's the cost of college. So that means you're in the negative. So that's that negative $20,000, $10,000 a year. But then by year 3, you start earning a salary. Whereas if you're going for an engineer, it's probably going to take 4 years of paying for college. So the number is you're getting a negative return until finally in year 5, that's $70,000. And it takes almost roughly 20 years for the engineer to catch back up with the person who went 2 years to college and then got hired on as either a process tech or a lab analyst. So 20 years is a long time. So, and that's not counting any appreciation on or cost of the money, interest rate or anything like that. That's just basically money coming in versus money going out. So very good paying job for the amount of education, a good return on your investment. In addition to money, there benefits in general, just the 401k programs, health, life, and disability insurance. These insurances often are provided for free to the employees or at lower than normal cost. There's also profit sharing programs and bonuses. When the plant does well, you do well, you get bonuses, and that varies from plant to plant how they're figured or how they're calculated. There's also stock purchase programs, which you can buy the company stock at a reduced rate in many cases. And so that's, if you want to start investing in stock, that's a good way to get started. And then also finally the paid time off, vacation time, sick leave, funeral, etc. The chemical process plants are probably as good as any job pretty much in the area. Okay, but it's both a pro and a con when it comes to working at the plants is the shift work. What I've always told people is you either love it or you hate it, and that may not be totally true. Some people you can tolerate it, and you don't really love it or hate it. But anyway, years ago, a lot of the plants around here had what was, they could just referred it simply to the 8-hour shift. But just recently did a little digging on the internet, and I saw some people call it the Southern Swing Shift, where you work 8-hour shifts, but that means you work 3 weekends out of 4. But keep in mind, all these plants run 24/7, so somebody has to be there on weekends and nights and holidays. But most of the plants around here have typically used what's called the DuPont schedule. And I guess it was developed by DuPont, but you have 4 crews, or you have shifts like we just had shifts A, B, C, and D, and there are 12-hour shifts. You have a day shift and a night shift. If you look at this calendar here, what it's saying here is, for example, you come in on Friday night, you work Friday, Saturday, Sunday night, then you're off 3 days, and you come back Friday days. On the 13th, 14th, you work 3 days. So after you work those 3 days, you're off 1 day, then you work 3 nights, then you're off what we call our short weekend. And then over here, looking at the 23rd, you'd work 4 days, and then you hit your 7 days off. And that's the great thing, when you have, in a 28-day cycle, you're working 7 days and 7 nights. So you're off basically half the time. Now, granted, a lot of times there may be overtime, but you're getting compensated time and a half for that. But that is what most of the plants around here have traditionally operated on. Now, recently, from what I understand, with the COVID-19 epidemic, they're trying to minimize contact between shifts. So a number of the shifts, maybe all of them, I'm not sure, but have gone to what the 7 on and 7 off. So with 7 on, I think most of them, or at least the ones I've heard, are going like from a Wednesday to a Wednesday. And you work, I think, 2 sets of days. You'll work a Wednesday day or 7 days, and then work another 7 days, and then you'll shift. And of course, you're off, and then you work 2 sets of nights, so 14. So in a month, you work 14 days and you work 14 nights. And you're really doing the same thing on the DuPont schedule, but they're broken down into smaller chunks. So there's that schedule. And then I'm not really aware of anyone doing the 4 on and 4 off, but that is another method. Now, maintenance, the 410s is really a schedule. I put that in there on this slide. It's not really it's not a 24/7 schedule, but some maintenance groups work what they call 410s, where they work Monday through Thursday. And there may be some analysts or in some labs where if you may have what we call day analysts who work the 410 schedule. Okay, so moving along, it looks like we're getting about out of time here. Safety at the plants is very good. So, always you hear that, I mean, there are dangerous chemicals, there's dangerous processes, but if you follow your procedures and you follow your protective equipment guidelines and that, it's a very safe place to work. And the data has shown that it's safer than many, what they're showing here. This was put out by the American Fire and Petrochemical Manufacturers. It shows it's safer than even a library worker. So as far as incidents reported. But another big part when you look at careers, what is the long-term job outlook? The plants have a lot of people who are getting on up there in age and experience, and there's a lot of retirees eligible now. We're thinking, the baby boomer generation, a lot of people are retiring. Also, this area with all the expansions, shale oil and gas has been, there's lots of cheap oil and cheap gas in the area. So a lot of the plants have done expansions. I know Formosa's kind of in the process right now of kind of wrapping up a big expansion they've done. I know Dow Chemical has added to their catalyst unit. And so that's great for the job outlook, whether you're talking lab analyst or operator positions. And finally, just these are some of the people that we work with here through our PTAC program: BHP Billington, Braskem, ConocoPhillips, Dairy Farmers of America, Dow Chemicals, Formosa Plastics, Ineos, Green Lake, Invista, Lyondell, Basell, and Seadrift Coat. Okay, so with that, if there's any questions, I'll be happy to try to answer them. And that's basically all I have. I know I probably spend more time talking about the industry than I did about lab analyst, but there's you know, if you're interested in, you like chemistry and you like numbers and math, you know, it'd be a good field to go into. Some of the pros of the lab versus working in operations, you're indoors in a climate controlled, you're not out there in the heat. It's a much cleaner job. You're not out there fighting, turning wrenches and that. It's more, you're wearing a lab coat and doing analysis. But with that, are there any questions? Okay, somebody asked, what kind of continuing ed does a lab analyst need? As far as continuing ed, there's always safety things or safety trainings you have to do. A lot of those are done online, and but also occasionally, you know, new pieces of equipment are brought in, and a lot of times the manufacturer or the provider of that provides training to the analyst so they know how to run it. Sometimes you may have to travel to Houston, because a lot of Houston is kind of a petrochemical giant, and so sometimes you might have to travel there to receive training. But you always, you know, it's always good when things are slow at work, you might be able to go on the internet and do some self-training to learn more about the equipment you're operating. But the biggest and most frequent is just safety trainings. There's a lot of required that are required by OSHA and your environmental agencies on requirements of how do you dispose of your hazardous waste, how do you handle your hazardous waste. Because after you test material, you have the material, you have to do something with it. So that's the bulk of continuing ed. Any other questions?